Hi, I'm Engineer Tolentino. Here's another video presentation from the ECE Department of Polytechnic University of the Philippines, Santa Rosa campus. I hope you enjoy watching this video.
Pleasant day, I'm Jasper.
I'm Feya.
I'm Joseph.
I'm Cici.
And I'm January.
And we are the 5th year ECE graduating batch of 2013 from Polytechnic University of the Philippines, Santa Rosa. As partial fulfillment for the requirements in the subject Thesis, we are here to present a video of our project entitled Application and Implementation of Ball Joint for Mass Support of Neck Mimicking Movement.
The human neck is one of the most complex parts of the human body, consisting of more than 20 muscles and 10 bones. Bones are responsible for structural support of the head, consists of 7 topmost vertebrae of the spinal cord and the atlas that supports the skull. Muscles are responsible for neck movements, namely upper extension or flexion, lower extension or flexion, swing, and lateral bending. The main function of the neck is to support the head. With this, the neck structure should be strong enough to support the head's weight. More than that, its strength is also responsible for the capability of the neck to maximize its mobility.
This study describes the mechatronic design of a neck robot that mimics the human neck motion and can support the weight of an actual human head. The basis of the neck design comes from previous neck designs and from the human anatomy. Comparing the mechanisms of the previous designs, the ball joint has the best characteristics and was selected. The sturdiness of the mechanism is also considered to support the actual human head weight and the accuracy in performing the 4 degrees of freedom, namely atlanto-occipital, lateral bending, rotation, and lower pitch.
The system presented in the study consists of a neck robot that uses a ball joint mechanism integrated with a revolute-like mechanism and a movement-sensitive controller that uses a potentiometer as a transducer. Servo motors were used as actuators of the neck robot. Proper placing, positioning of the servo motors was carefully monitored. Also, the torque needed to support the actual human head weight was thoroughly calculated to get the accurate value. Using the calculated value of torque, the proper position of servo, the accurate motion sensing controller, and the prototype, the study was implemented.
This study used different significant methods in developing the project: data research, verification through computations, drawings with the aid of AutoCAD, and simulations using Autodesk Inventor Professional are some of the methods. The collected data were successfully implemented in the construction and completion of the project.
And now, let us proceed to the presentation of our prototype. Hey, are you ready?
Now, here's a demonstration of our prototype. First, rotation movement. It is the movement of the neck from left to right, creating a no motion. It ranges from negative 90 degrees to 90 degrees. Next is the lateral bending movement. This neck motion ranges from negative 45 to 45 degrees. It is the movement where the ear almost touches our shoulder. Third is the atlanto-occipital extension and flexion. Its motion is the same as the fourth movement, which is hyperflexion and extension. The only difference is atlanto-occipital uses the atlanto-occipital joint and the C4 to C5 vertebrae of the spinal cord. It is the nod motion of the neck, ranges from negative 30 to 10 degrees. And lastly is the hyperextension and flexion. It is also a nod movement of the head that ranges from negative 10 to 30 degrees. And that's how our prototype demonstrates the movement of different neck motion.
Hope this video presentation will be useful and inspire future innovators like you. For more video presentations, just click on the link that will appear on your screen.
Thank you for watching!